Welcome. In this video, we're going to continue our exploration of quadratic functions. As you can see here, there is a quadratic function in blue to the right of your paper, and that is the graph of this function here. Let's look at part A. Let's find the x-intercepts of this graph, and in order to save time, we're going to use technology. Since I've already done a couple videos showing you how to use the quadratic formula, let's use technology. So here you can see I opened up GeoGebra's Graphing Calculator app, and let me resize the screen. There we go, so we can still see part A and our graph. So let's go ahead and type in the letter F and then go f of x to have our function notation equals x squared minus 3x minus 6.75 and return. And this doesn't look that great, so I'm going to resize this. There we go. That gives me a much better view. And let me pinch horizontally. Perfect. So here is my first intersection. So the first intersection is negative 1.5 comma 0, and that is as an ordered pair. And the second intersection here is 4.5 comma 0. All right, now let's continue. Let's find the average values. Find the average of the two x values we found in part A. And since space is limited here, I'm going to work out the solution for this problem up above. And we're just going to find the average of the x values. So negative 1.5 plus 4.5 divided by 2. In the numerator we have 3, in the denominator we have 2, so this is 1.5. Let's continue. Let's substitute the average x value we found in part B into our original equation in order to find the corresponding y value. All right, so let's try this out. And I'm going to do this in blue. So f of 1.5, we replace every x with a 1.5. And you can do this either manually or pop this into your calculator. Either way, you'll end up with negative 9. And that is this point here. Let's find that. 1.5, negative 9, right here. This is the vertex of this graph. And you just found that by averaging the x values of the two x-intercepts to get the x value of the vertex, and then you evaluated this function at this x value to get the y value. Now let's verify this value of our vertex using technology. So again, I have GeoGebra up, and right here you can see my graph is still there, and there it is, the extremum. The vertex is at 1.5 comma 9. Let's continue. For any quadratic equation, ax squared plus bx plus c equals 0, we can use the quadratic formula to find the two intercepts. According to the quadratic formula, we have these two solutions. We have the solution with the positive and the solution with the negative. That's not to say that this was necessarily positive and this was necessarily negative. We just see this difference in sign. Now we can average these two x-intercepts together to find where the vertex is located. And I went ahead and did this sort of tricky algebra for you. I added these 2 points and divided them by 2, these two x values more specifically. Here I've combined like terms. This value plus this minus this value, since they're equal, becomes 0. So this is what we're left with. And then here we simplify using algebra. 2 over 2 is 1. When you divide a fraction by a whole number, it's like multiplying 1 over that whole number. And we end up with x equals negative b over 2a. And this is something I've already hinted at and shown you before. The x value of the vertex of a quadratic equation is negative b divided by 2a. How can we use this in application problems? The profit function for a small business is given here, where x is the number of units produced and sold. How many units should the business aim to sell in order to maximize their profits, and what will the profits be? Before I read the ending, I think that gives away a little too much. I'm going to show you what this will look like visually. So again, this is a quadratic. P of x I don't need the p of x. So this is of the form ax squared plus bx plus c. And these will look like they're upside down. So we'll get an upside down quadratic, upside down parabola that is, when a is negative. So a is less than 0. And in our case, a equals negative 4.1, so a is definitely less than 0. Well, how does this help us? Well, let's see. Our x-axis represents units sold in this direction. And in the vertical direction, it's profit. That means we're going to get some ordered pair, and let me change color here, x comma y. Y is at the very top in this case, so this is the maximum profit, and x is the number of units sold to maximize that profit. All right, so now let's use the formula we just found in question 2 to answer this question, then use our technology's graphing utility to check. So let's write this down, negative 4.1x squared plus 147.15x minus 567. That is my function that models profit. So a equals negative 4.1, b equals 147.15, and c equals negative 567. Now x in this case is negative b over 2a, and that's the x value of the vertex, which we're looking for here. So this becomes negative 147.15 divided by negative 4.1, and of course I have to multiply by 2. And using a calculator, this will simplify to about, and I'm rounding, 17.95 units sold. Now realistically, no one sells part of something. You don't go to a car dealership and say, I want 95% of the car. So, take out a seat. That doesn't happen. So let's round up. I'm going to say for reality's sake, because realistically, no one's going to sell you part of something. Now, so what I'm saying here is that our profits are going to be maximized at about 18 units. And then what is that profit going to be? So what's the profit of 18? And for all of this, I'm just going to go ahead and use technology. And here I have my old function. I'm going to delete that. And I'm going to go ahead and start here with p of x is equal to negative 4.1 x squared plus 147.15 x minus 567. And I can't really see anything, so let me squish this down and resize. Oh, there I go. There we are. And so there is our extremum. Look at that. 17.95 is pretty good. And our profit function evaluated at 7.95 is approximately $753.31. What about for 18? What about for 18, since that is our estimate? So let's go and create a table of values, and we really only need 18, so let's just go from 18 to 18. Oh, I have to have one bigger and smaller. Okay, so let's go, fine, from 17 to 18. There it is. So if you notice at 18, our profit is $753.30. So it's a penny lower. So, it's still pretty close to the max. So P, our profit, at 18 units sold is about $753.30. Now, how would I actually answer this? I would answer by saying their profits will be maximized after the sale of the 18th unit, and their profits will be maximized at $753. And I guess I could say of approximately here, since I am rounding. I hope this video was helpful.